In this chapter, we're going to take a look at sets and maps. They are both part of Java collections. In this video, we're going to take a look at sets. So here's an idea of where you might use something like a set. So we think about the no-fly list. It's created by the government's terrorist screening center, and it's a giant list of people who are not allowed to get on commercial aircraft in the United States for safety reasons. So suppose we need to write a program that checks whether the person is on the no-fly list. It's a pretty long list, and it needs to be pretty efficient and pretty fast. We don't want it to take a long time and have the person end up getting through because we were waiting on the system. So we could use a list to store the names in a no-fly list, but a list isn't very efficient. It takes time, a lot more time to search a list than it does to search a set. So a set is more efficient when we're doing basically the dot contains method. If we're looking to see if some kind of collection contains something or not, a set is the most efficient way to go. And then later on, we're going to talk about maps. And then once we find information about a person, we could look that person up by their name and then find the other things associated with that person, like their gender, their height, their weight, or their nationality, using their name as a key. And we'll talk about that later on with maps. So let's take a look at the collection framework hierarchy and talk about how these things all fit together. So at the very top, we have collections, and in previous chapters, we've talked about list as an interface, and we talked about abstract list being a partial implementation of the list interface that's provided for us in the Java framework. And then we talked about the concrete classes, array lists, specifically quite a bit. We talked a little bit about linked lists, but now we're going down a different line from collection, and we are going to be looking at sets. So this is the set interface. So everything to the left of this dotted line here in the collections framework is interfaces. So the set interface extends the collection interface, but it doesn't introduce any new methods or anything. What the set interface does is stipulates that a set can't contain any duplicate elements. Any concrete classes that we create, like hash set or tree set, which we'll talk about in a little bit, have to ensure that no duplicate elements could be added to the set. Then if we follow the dotted line down here, abstract set is an abstract class that implements the set interface. Okay, so it's a convenience class that extends the abstract collection from here, extends the abstract collection and set. It provides concrete implementations for the equals method and the hash code method. And those are pretty important things because the equals method and the hash code method both come from the object class. Okay, so hash codes are a way to take an object and generate a unique code for that object that will tell us very quickly whether it's equal to another object. So for an integer, the hash code is the integer, basically. For a character, it's the ASCII code for the character. For a string, there's a big formula where it adds up basically hash codes multiplied by some factors for each letter in the string and adds them all up to get this unique hash code. Dot equals compares two objects' hash codes to see if they're actually equal. Okay, so that's how dot equals functions so efficiently. So abstract set actually implements those two methods, overrides them from the object class so that we can use it. The hash code of a set is the sum of the hash code of all of its elements. So this is an abstract set. All right, now let's talk about sorted set. So sorted set is a subinterface of set. It guarantees that the elements in a list in a set are sorted. And the concrete implementation of a sorted set that we're going to talk about today is tree set. And because tree set has an order, we can use an iterator to go through it in order that the elements were added. And we can also sort them. Hash sets or regular sets have no order to them. Tree sets have order. So the hash set class is a concrete class that implements set. It can be used to store duplicate-free elements. We're guaranteed that there will be no duplicates in a hash set. For efficiency, to do that, again, they need to implement the hash code method that we said was given to us in a concrete in an abstract class here and inherited initially from the object class. All right, to break this down, collection interface, we've talked about that quite a bit, and the methods that the collection interface contains. We talked about that back when we did lists. So let's look at the set interface hierarchy. This is basically this diagram turned sideways, and we got rid of all the extra stuff with lists and queues out of it. So we can see how the set interface actually is organized. We have the set interface, which implements the collections interface. The abstract set implements the set interface, and then hash set inherits from that. Linked hash set inherits from it. Tree set also inherits from it. And then we have the sorted sets and navigable sets, which enable us to do also the tree sets. So this is kind of the structure of all those classes and how they abstract classes and interfaces and how they fit together. All right, that's enough of the overview. In the next video, let's take a look at some actual examples of implementing some of these things, hash sets and tree sets and sorted sets.